Hello everyone, welcome to our lab. So this is in our Penborn Beauty. So we're going to do our experiment. We're going to do impact testing and we're going to do harness, and this is like 3-point bending tool or tensile stress tool. So today our first course is that we're going to do impact testing. So when you start in the lab here, you can see me. I put on my goggle because when we do this test, there might be some debris flying out and hurt you. So you want to make sure you wear the goggle. Usually we don't wear a mask, but this is a COVID situation, so you wear everything. So you probably couldn't see me, the real me. And you want to have a closed-toe shoes here and long pants. Okay, so this is pretty standard for mechanical testing lab. So first of all, you will see on your blackboard is the instruction for the impact testing lab. Okay, so all the operation could go step by step, and I will walk you through step by step here too. And there's a one-page data sheet. Okay, remember you want to finish that data sheet and complete in a week. Okay, so that's very important. That's very heavy weighted for your final grade. So let's start with talking about this tool. We're going to test the impact testing. Impact testing, we talk in theory, is testing the toughness of a material. It's really what's toughness. It's how much energy this material can assume and can consume or absorb before it break down, before it crack. Okay. So if you look at the stress and strain curve, we talk about stress and strain curve is linear, elastic, and plastic, and the area below that curve is the toughness. It's basically energy absorption for this material. So toughness is things could be hard, strong, but brittle. Okay. So low toughness, we call this material brittle. Large toughness, we call this material is ductile. Okay. So we're going to test three material. One is PVC cube, okay, rod, and the other is like half depth of this PVC rod, okay, and there's a wood piece, okay, and you can see there's a notch or cut here in the middle, and that could tell that was designed for the impact tester. Okay, if you look at this we call Sharpie impact tester. Okay, what it does is that you can lift up high. Okay, lift up high enough. Okay, this is the hammer, and you put your sample here. Okay, and you have an indicator, which is the energy absorption indicator. And you pull this, or you press this. Let me see. Sorry. You turn this, okay. And this hammer comes down and break or strike the sample. Okay. One thing I want you to make sure when this hammer is lifted up, I want all this space is clear. Nothing can be crossed over this space, okay? Because anything happen, you can break your finger, your arm, or anything else, okay? So when this is lifted up, I want nothing underneath, okay? So when you want to put your sample here, you really want to have someone else holding it, and very low, okay? When that's high, I don't want to do this. So this is Sharpie. And that's in IZOP. Okay, I'm gonna do that later on, but this is something I want to go from one at a time. Okay, so if you look at your instruction, okay, how are we gonna do with this Sharpie impact testing? Okay, first of all, you measure the dimension of your samples. Okay, let me get a pen. Measure the dimension of your sample. Okay, So if you look at the data sheet here, okay, put on what kind of spacement here. This is a, so we have three, this is a wood, and this is a PVC. You can say this is a thicker rod, and this is a thin rod. You got two things. Okay, so I'm gonna write it down. Wood. Okay, PVC plastic, thin. PVC, okay, thick. And color code, you can put on what you observe here. Then you put the dimension here. Okay, I hope everyone know caliper, how to use a caliper. So you can see the up dimension is in millimeter, the lower dimension is in inch. Okay, so how we use a caliper is that we put our sample here. Okay, this is the length. You can see this is 100 millimeter. Okay, exactly 100 millimeter. So this is each unit is 10 millimeter, and here each unit, each small indication here is the 0.1 millimeter. Okay, so make it all. If you make all circle, that's 10 millimeter. If you make it just from 0 to 1, that's 1 millimeter, and the smallest unit is 0.1 millimeter. So if you are I want you to do scientific estimation of the decimal. Okay, so here, if you can see, this is 100 millimeter, and if you look at this is 0, and this over between 0 and 0.1, right? So you can see this is 100.05. You can do that estimation, but I want you to do a scientific estimation of the decimal. Okay, so you can look at this. This is the length. Okay. Okay. Okay, this is the length, and this is the width. Let's do the width. Okay, I want you to see carefully in my caliper and write down the number. This is the width. I'm gonna write it down too. This is 10, 13.1, 2, 3, 4, 5, 6, 7, 8, 13.85. Okay, and this is the depth. Okay, this is 10, 14, 1, 2, 3, between 3 and 4. Okay, notch location is from here to here. Do estimation. It's really a 50.12 between 50.2 and 50.3. So I estimated 50.25. Okay, now we measure the thin one. This is the length. Thin PVC plastic. Okay, this is not at 100 yet. Okay, this is 100. Oh, this is over 100. 100.1, 2, 3, 4, between 4 and 5. Okay, estimate what's the length if you know how to read it. This is the width. This is 14.2 and 3, between 14.2 and 14.3. And the depth. That is 6.8, between 6.8 and 6.9. Notch location. is 49 or 48.78, between 0.7 and 8. Okay, and this is last piece, wood piece. Let's do it. This is the length. What's the length? It's 100, between 100.5 and 6. Do the estimation. This is the width. This is 10, 14.12, between 14.2 and 14.3. And this is the depth. This is also 14.4 and 5. Notch location. It's about 49.4 and 5, between 49.4 and 49.5. Okay, we have get all the dimension. Then we're gonna do the testing. Okay. Follow the instructions. Second, place a Sharpie spacement horizontally across support with the spacement to the right of hammer and the notch face away from the hammer. Make sure the spacement is centered with the anvil jaws, and rotate the pendulum to the left until it's fully locked to the test position. Okay. Keep everything and body part clear from the pendulum motion to avoid accidents. Okay, make sure to do that. And set the pointer to 15 joule. Okay, so this is what we're gonna do. We put the sample here. Okay, so this is a two-side support, just like this one. Okay, so the notch should be away from the hammer. Okay, so if you look at this way, this is a two-side support, so the notch should be away from the hammer, facing back. So that will be the center of the stress, and center it. Make sure your one hand is tightly holding it. Okay, so put that here tightly, and then we are ready to go to the highest position on top. Importantly, the indicator should go down to 15 joule. Okay, 15 joule. That is the maximum of energy this tool can measure of the absorption, or this hammer coming down can apply to the system. Okay, and if you go down, and this indicator will turn to the point that like how much energy or how many joules that this sample is absorbed. So the indication showing the energy that this sample absorbed. Okay, the energy absorption. So point down to 15 joule and make a turn of this knob. Okay, ready, set, go. Okay, so you can see that the sample getting out and break in half. Okay, that absorbed the impact and it fully break. So until you fully stop, it's gonna take a while. So I'm gonna show you how to read this table. So you can see that it is like point at 2 joule place. Means this piece of sample only absorbed 2 joule of the 15 joule this hammer applied. Okay, so this is actually 1.90 joule. I will say 1.90 joule. Okay, so I will say the same one is 1.90 joule. Oh, sorry, 1.90. Okay, 1.90. Then let's do the thicker one later on. Hold on with your hand and put this piece against it. I remember this won't be stable because it is really too strong. Sorry, it's too thick. So I want to find something to hold it. But not with your hand, right? Not with your hand. So this is too thick, so I just use something to help me hold it over here. For the spaceman not falling off, and put all the way up. Okay, when this up, don't put anything in between. Okay, and turn this back down to 15 joule. Okay. Ready? Set, go. Wow, it's pretty powerful, right? So the debris fly everywhere. I couldn't even find one. But this is the broken part. Okay. So let's read how much energy was absorbed. So it's showing here is 2.55 joule was absorbed. Okay, it's 2.55 joule was absorbed. Okay, so you want to read that. Okay. The third one, I won't help you read. I want you to read, give me an estimation, scientific estimation of a decimal. And the third one is the wood piece. Okay, we're gonna put it on. Okay, we'll put on the wood piece. Hold on your sample. It's also very thick, so I want something to help to hold it here. And lift the hammer up. Reset the indicator to the lower part, and one person just rotate it. Okay, it wasn't very successful, I think. Let me get another piece. And wood is pretty tough. There's a lot of energy sorting that could happen here for wood. Okay, for this wood piece, apparently it absorbed all the energy from the hammer, okay, without breaking off. So come here and read it. It's basically 14.95 energy was the source. Okay, this is what we have here. Okay, so the later part, we're gonna, so this is the indicator. This is to help you directly read the energy absorption, right? If this swing higher, means there are less energy absorbed. This swing lower means there are a lot of energy got absorbed, right? Okay, so I would like to move on to the IZAT, but will we pause? Okay, so ready to start?
Yeah.
Okay, so we're gonna do this called IZAT tool. IZAT is not probably is a little, almost everything's the same with this Sharpie tester, that one we showed. The only difference is will be that they don't calculate the energy for you. Okay, they're gonna ask you to do the calculation yourself. Okay, so that's a major difference. So what this is different, let me say it again. Okay, when this is hammer is up, then all the reading is not showing you the energy of absorption. How the reading is showing you the angle. Okay, so it's telling you that this angle here, this angle is 150 degree. Okay. When the hammer comes down, swing down and strike a sample, and you will move this indicator to how far you could go. I think the highest where there's nothing, you can go to 150 degrees. So that if there's no any energy get absorbed, right? But most of the case, it could be 180 different kind of energy you're measuring. So basically that is calculating, you need to do the calculating. When this is high, there's a lot of potential energy as I talked about in the last class. A lot of potential energy, you need to calculate the potential energy, which is mgh. M is the mass of this hammer, g is the acceleration of gravity, is 9.81, and the h is this high. Okay, this is potential energy. When this is released all the way down, hit the sample, all the potential energy transfer to kinetic energy to strike and have a speed to strike the sample. And after that, the energy gets absorbed. There's some remaining energy that could swing this hammer up again to a certain degree. Okay, so we need to calculate what is the initial potential energy and the final potential energy. So you want to measure the mgh here. The final potential energy, and this difference from initial and the final is how much energy gets absorbed from your three pieces. Okay. So we're gonna do that again with the three pieces. Okay, so I want to do a measurement for you again for these three pieces. So you come closer. But I won't read to you. I want you to do a scientific estimation. I will write down my answer, and you're going to write down your answer. This is the length of this thing, PVC, 100. See it? Okay, this is the width. .14. And this is the depth. The notch location is here. Okay, this is a thick one, thick PVC. This is the length. This is the width. And this is the depth. Okay, last one is the wood piece. This is the length of the wood sample. This is the width. And this is the depth. Okay, so let's get our started for our experiment. So let me put on my goggle, which is having some problem. pretty big.
Yeah.
Okay, so let me put on the sample, which is let's start with the wood piece. Okay, so when you put it on, just put your sample in. Okay, so this is a standing sample set, right? So the notch should face the hammer. Okay, it's like this. So notch should face the hammer. Hold on here, but this is not tightly sit, so I put a spacer there. Okay. Okay, let's go all the way up. And put this indicator down to 0. Okay, so the hammer weight, we know that this weight is that's written in your data sheet. The weight is 7.3 kilogram force. Okay, what is kilogram force? Kilogram force is basically the weight. Basically, is the mass time the gravity of acceleration of gravity. Okay, so you want to figure out the weight of this hammer is 7.3 kilogram force, and the angle here is 150 degrees C. So calculate how much potential energy here, and then we're gonna see after the strike how much potential energy, which is what's the angle there. Okay, so let's get started. Let's go. Okay, so this strike very high over here. Okay, if you look here, the sample got strike off, but it stuck over here, so you stop the hammer, but it really strike off. Okay, and then we can see what's the angle here. This is 0, 10, 20, 30, 40, 50, 80, 90, 100, 110, 120. I would say 120 and between 120 and 121. So do the estimation, I will say is 120.5. Okay, that's the wood piece here. Okay, let's do the plastic thick first, later, okay? Plastic thick, I put it in. Now lift the hammer up, nothing in between here right now, and put the indicator to 0. Okay, see how far it can swing up. This is a thick plastic PVC. Let's go. Okay, it strike all the way back, and the angle is. Let's get closer to read the angle. We were at 120 for the wood. This is 130 and 130, 135 and 136. It's very close to 135. Do some estimation. Then we're going to do the thin piece, okay? Go all the way up and put the indicator down. That direction is potentially dangerous. The sample might strike over there. Okay, see how high this is going to swing off. 1, 2, 3, go. Okay, this is what we have. It starts at 150. This small piece doesn't absorb much, so you go to pretty much is 139 to 140. Right? Okay, then you want to calculate what is the initial potential energy, what is the final potential energy by using the weight and also the angle, and you calculate the difference to tell me how much energy is stored. Okay, so if you look at the data sheet here on the top, remember put on your name, your UID and course session. Very importantly, note here, data sheet should show all the work of data processing or calculation. If you need extra space, use extra papers, but you want to attach all the related work. Okay, I want to see your calculation and everything, see if you understand it. I think that is our demonstration for this course. Let me know if you have any question, and I will see you live online to discuss if you have any question. Take care. Bye-bye.